Welcome back. All right, let's talk about continental drift. We don't usually use that term anymore, kind of when talking about our current understanding of plate tectonics, but it's important to know the history of plate tectonics. So let's talk about continental drift, shall we? So, some early ideas about continental drift. There's a few people that kind of had some ideas about what they thought was maybe going on. Let's start with Edward Suess. He was an Austrian in the late 1800s. He kind of noted similarities between certain plant fossils, specifically something called Glossopteris, as well as evidence of glaciation in rock sequences in India, Australia, South Africa, and South America. He's like, so basically what he says is like, all right, wherever we see these fossils, we always also see this kind of weird glaciation. So kind of just putting some things together. So he proposed that, where they find both of these things, maybe these were all connected at one point. And he proposed the name Gondwana land or Gondwana for a supercontinent composed of these continents. He didn't really kind of picture and put it together, but he just kind of had these ideas. Maybe they were stuck together. This is the fossil of Glossopteris. It's like a leafy tree. And when we look at a map of where this kind of fossil is located, it's the green one. So again, through South America, through Africa, India, Australia, and even, as we know now, in Antarctica. Okay. Additionally, I don't know why that's there, he also noted glaciation. In those kind of same continents, there was also these glacial striations. Glaciers move, and when they do, they kind of carve the rock underneath it. So he noticed that there was glacial movement also in these areas. And I don't know if you know much about, Africa, India, Australia, or this part of South America, but it's hot. There's really no glaciers there now. So how can we, in these places that are extremely hot, how can we find large areas that were covered with glaciers as evidence of these scratches in them? So anyway, he said, the same place we found the glacial evidence, we find these fossils. All right, continuing on, let's talk about Frank Taylor, who was an American, early 1900s. He came up with a hypothesis of continental drift. So a hypothesis is just an educated guess, and it had some certain features. That continents must drift around because the lateral sideways movement of continents help to form mountain ranges. So they must move and crash into each other to form mountain ranges. That was kind of his idea, not necessarily the reality, but that was his idea. A particular continent broke apart in the middle of the Atlantic Ocean. That's kind of his one piece of evidence he thought occurred. He didn't, or one piece of information. He didn't have evidence, but this is kind of what he was coming up with. And supposedly, tidal forces pulled polar continents towards the equator. So as the Earth is spinning, somehow that pulled continents that were colder near the poles towards the equator, warmer regions. So for instance, India, very hot. Maybe at one time it was in a different location near a north or south pole, but as the Earth spun, it just kind of pulled that chunk of land towards the equator. And that kind of occurred, that should go with the, the last bit, when Earth captured the moon about 100 million years ago. That's not necessarily the truth, but the moon's much older than that. But his idea is like, okay, somehow when the Earth caught the moon, that helped to also create these forces that brought these land masses to the equator. So, keep on going. Let's go to probably the most important person in this story, Alfred Wegener. So the W is like a V when you're talking about German words. So he was actually a meteorologist, not a geologist at all. So Alfred Wegener, so just a couple of years after Frank Taylor, I forgot his name, also created, or also is more credited with the hypothesis of continental drift. He had a little bit more. So he's kind of the main person. When you talk about continental drift, Wegener's the guy. Even though others kind of had these ideas, he kind of more solidified it. So he proposed that all land masses, not just a handful of them, all land masses were originally united into one supercontinent. He called it Pangaea or Pangaea, depends on how you pronounce it, from the Greek word meaning all land. He also presented a series of maps showing them all connected, but then the breakup of Pangaea itself. And he amassed a tremendous amount of geologic, paleontologic, and climatologic, evidence. So others again were before him, but he really put everything together to say, you know what, continents are drifting around. We're still calling it continental drift at this point. So again, his evidence was looking at the shorelines. He was looking at a book or a map of the Earth, and he said, you know what? It looks like the shorelines of continents kind of fit together. So he just cut them out and kind of put them together and said, oh yeah, they kind of all fit together. They must have been together at one point. They match in marine and non-marine rock sequences, as well as glacial rock sequences. And that existed from the Pennsylvanian to Jurassic Age. A little bit, we talked about that in Unit 1, but we'll talk about geologic age in Unit 4. And that also was true of all 5 Gondwana continents: South America, Africa, Antarctica, India, Australia. But now he made the connection as well from Eurasia, Europe and Asia, and North America. So it wasn't just Gondwana, it was these other ones as well. He also connected mountain ranges and glacial deposits and showed how when these are connected, these things kind of match up. So let's take a look. So there are certain mountain ranges. Once you kind of arrange all the continents and fit them all together, you'll start to see how certain mountain ranges of rock types and ages start to kind of match up. And there's some over here. Oh, excuse me. When you match up all the continents and you look at that glacial movement, those glacial striations and glacial evidence, you'll see that it kind of all matches up. They all flow away from one particular spot. That must mean at one point at the south pole of the Earth, Africa and all these other things were down there to have this intense glaciation. So he kind of put it all together, including, again, North America and Eurasia, not just some of the lower continents. So anyway, Alfred Wegener, kind of the guy. Additionally, Alexander du Toit, South African geologist in the 1930s, proposed that a northern landmass known as Laurasia consisted of present-day North America, Greenland, Europe, and Asia, except India, and so is that part and Gondwana kind of coming together and or separating depending on when you're looking back in time to form Pangaea or Pangaea. So that helped to provide additional, and he also, provided additional evidence for continental drift. So looking at not just Glossopteris that we see again in South America, Africa, India, Antarctica, and Australia, but some of these other fossils as well. You know, typically when you're finding fossils of a particular organism, they only exist in one area. For instance, like in modern day Australia, kangaroos only exist in Australia. So we wouldn't expect to find kangaroo fossils elsewhere. But in the future, millions or billions of years down the road, let's say there's 2 separate land masses and we find fossil evidence of kangaroos on one and kangaroos on the other. Well, at one point, they must have been together because, again, organisms tend to kind of stay together. You don't find kind of random organisms elsewhere. If so, then evolution takes place and those organisms evolve and a little bit different. But in any case, Synognathus, you can find those fossils not only in Africa but in South America. Mesosaurus, you can find those fossils not only in South America but in Africa as well. Lystrosaurus, you can find those in Africa, India, and Antarctica. Again, you can't find the same fossil on separated different continents. There's going to be variations. There's going to be differences. It's not going to be the same exact thing, right? Yes, there are, hawks in North America, and there's hawks in, say, the Middle East. but they're different. They've evolved differently, size, beak shape, whatever. All right, but if they're similar, then they had to be around the same area, and all of that makes more sense once you put everything together. The problem, though, with continental drift, again, this is an early idea. There's a big problem with that. Most geologists at the time did not accept the idea of moving continents. They were called fixists, and the main reason because there was no mechanism to move the continents around. So, okay, there's evidence that they had moved around, but what's driving that? What's creating that? No one knew what the driving mechanism of this was. So, that's kind of where this is kind of dying down. However, interest in continental drift kind of revived starting in the 1950s, so for about 20 or so years, when we started to have submarines and use sonar to map the bottom of the ocean, as well as looking at magnetic fields, so different scientific tools to look at magnetic fields. So once we started to get this additional evidence, looking at now we are able to take images of the seafloor with sonar, and we can look at the magnetic field of the Earth and look at that back in history. More on that in the next section. Then people started to say, wait a minute, there is some evidence here that plates move around. There is some evidence here. This is it. We're starting to find a mechanism for all of this. So continental drift as an idea started to die out, but again, there was this evidence that started to pop up. And that's what we'll kind of talk about and get into in the next section. I'll see you there in just a second.